remember something if it makes sense, rather than me just saying memorize these 10 things. Let's see if it makes sense. So I kind of set this up as a table for you. What I'm going to do is, in this first column we're going to write out the rule, but over here we're going to kind of use an example to figure out why it is what it is. So if I said like 5 squared times 5 to the third. What does 5 squared mean?
25.
Okay, how'd you get 25?
5 times 5.
Okay, 5 squared means there's 2 5s multiplied together. That's my 5 squared. What does 5 to the third mean?
125.
How'd you get it?
5 times 5 times 5.
Okay, 5 to the third means there were 3 5s. So when I multiply those all together, how many 5s do we have? 5. So it's 5 to the fifth. So the question is, what do we do with those exponents? Add them. So a to the m times a to the n is a to the m plus n. These exponent rules, if you don't remember the rule, back it up and think about a problem. If we work it out, what does it mean? All right, second one. A to the m to the n, a power to a power. So if I said 5 squared to the third. Okay, we know 5 squared means 5 times 5. What does that third power mean?
Multiplying the exponent.
Yeah, it's saying we have this, whatever's on the inside, 3 times, right? So I have a 5 times 5, 3 times. So altogether, how many 5s did we get?
6.
So the rule, we're trying to figure out, what do we do with those exponents? Do you remember doing this before?
Yeah, this is one of the last things.
One of the last things you did. Does the justification make sense if we're writing out some examples? Okay. Alright. So AB to the n power. What if I wrote 3x squared?
You have 2 there.
Alright, we have what's inside my parenthesis twice. So we end up with we have 2 3's and 2 x's, or 9x squared. So we took that 2 and distributed it to both of them. So this is an a to the n and a b to the n. So if it's just one term on the inside, so everything on the inside is multiplied together, then you can distribute that exponent. Few more. If we are dividing, so if I said 5 to the 4th divided by 5 squared. So 5 to the 4th means there are 4 5s. 5 squared means there are 2 5s. What happens? Yeah. We can cancel some of those out and we're left with 5 squared. So all we really had to do was subtract the exponents. See, you guys didn't know you remembered so much, did you? Thought you forgot everything. Rule number 5 is really like the third one. When things are multiplied, we can distribute that exponent. The same is true if they're dividing. If I said like 5/3 squared, that means you have it twice. So you end up with 2 5s on top and 2 3s on the bottom. So when we are dividing, we can also distribute those exponents. Couple more, these are more notation things than actual rules. If I have something to the 0 power, so if I said like 5 to the 0, that means I don't have any 5s. So what do we say that's equal to? 1. Any number to the 0 power is 1, always. All right. And the last one, this is just a notation. What does a negative exponent mean? Changes floor. So if it's a negative, it would drop it down to the bottom. If it was on the bottom, it would go up to the top. All right. So far, so good? What I want you to do, let's see if we can figure out a few. So I did not put these examples on there. I apologize. There's probably some room on the back where you could just write some of the examples. I took some shortcuts when I was typing and didn't type out all the problems for you. So, what would that equal?
14.
We're multiplying, so we just add those exponents. You'll notice the directions. It's always going to say, assume the variables are non-zero real numbers. It really doesn't change anything. They're non-zero because some of the rules don't work if you have 0 to a power. You can't put 0 on the denominator and things like that. Don't let the directions confuse you. We're just doing our rules of exponents. So here, when we multiply, we can do that in any order. So we could go through and multiply all of these numbers together. Okay? If you're rusty, you're welcome to grab a calculator, but I think we can do it. What's negative 5 times 6?
Negative 30.
And then negative 30 times negative 3. Okay, what would I do with my r's? What if I just have this r here? What's my exponent?
1.
So 3 plus 4 plus 1. So 90 r to the 8. What would I need to do here?
Multiply.
Yeah, multiply. The 4 has to go to both of these, and you multiply their exponents. So we would get 2 to the 20, because it was to the 5th and then to the 4th, so we multiply. And y to the 12. Okay, notation-wise, 2 to the 20th, you could work that out. It is a huge, huge number. I am okay with you just leaving it like this. You know, if it's something like 2 squared, go ahead and do that. But if it's going to be a really big number, you can leave it to a power. I don't care. All right, last one here. Right, so I have to square everything in this parenthesis. So negative 3 squared. Positive 9. That means negative 3 times negative 3. So positive 9. A to the
6.
over
B squared.
C
C
to the 8.
Very nice.
Would we have to do anything else with that problem?
No. If it's, and we'll get into some, like if you could simplify, like if you had 9 over 18, you know, reduce that, but otherwise you can leave it. Alright.
Can you not put down like the square?
Well, that's what we just did. We undid that.
Yes, so yes, you could break them down by a square, but it would just take you back to the original problem. Okay. I want to put 3 problems up here. And I just want you to take a second and see if you can figure out what the answer would be on each. So, first one, 8 to the 0. I told you anything to the 0 power is 1. Okay, second one, trick question. What's the difference between B and C?
You're not multiplying negative.
Right. I kind of put this in, if you were to plug these into your calculator, you get 2 different answers because exponents apply to what's directly in front of them. If that negative isn't in a parenthesis, this is like saying the opposite of a to the 0 power. So a to the 0 is 1, but the opposite of that would be negative 1. Now C, the negative is in the parentheses, so it's that whole thing to the 0. So that one is 1. So 1, negative 1, 1. All right. Questions there? Let's go over, if you go back to the front, some of the terms. So I am not going to test. I'm not going to ask you to write definitions. I'm not going to have a fill-in-the-blank section or anything like that. When I give you terms and definitions, it's just because these are words you're going to hear me say. So I want you to know what I'm talking about. Okay, I'm not testing you over the definitions, but I want you to know when I say these words what I mean. When we talk about an expression, that just means it doesn't have an equal sign. 8x is an expression. 3 plus 5 is an expression. Anything without an equal sign is an expression. Terms. This is very, very, very important. We will come back to this one a lot. Terms are separated by addition and subtraction signs. So we have a lot of rules that apply to things that are 1 term versus things that are 2 or 3 terms. And so we have to know what we're referring to. So a term, like 3x squared, is a term because there's no addition and subtraction. If I say 2 plus 5, how many terms is that? 2 terms because there's a plus in the middle. If I said 3xyzw minus 4, how many terms is that? 2. They're just separated by the addition and subtraction. What does it mean if I say like terms?
Like 3x and 3x. Or
Right.
3x and 2x.
Good. The variable parts match. So like terms have the same variables to the same power. Within our terms, we'll talk about monomial, binomial, trinomial. What does monomial mean? 1 term. Binomial, 2. Trinomial, 3. And then anything beyond that, what do we just call polynomial? Just means more than. All of those are technically polynomials as well, but anything beyond that we just refer to as polynomial. The key, if it's a polynomial, your exponents are whole numbers. What are whole numbers?
Non-negatives.
Non-negative, no negatives, decimals, 0, 1, 2, 3, and so on. So you're not going to have fraction exponents or negative exponents or decimal exponents when we're talking about polynomials. They're all nice, pretty numbers. So far, so good? Just a few more pieces and then I'm done with that. We already talked about polynomials. Coefficient. What's the coefficient? Right. If I said 5x squared y cubed, what's my coefficient? The 5. degree. Yeah, it's the power. The degree is like saying how many variables are there. So if I said, 4x, the degree is 1, because it just has an x. If I say negative 3x to the 5th, the degree is 5. In this one, what would my degree be?
3. 5.
It's actually 5. Why?
Because you add them.
Yeah, these are all one term. Degree is like saying how many variables. Well, in this term, we have 2 x's and 3 y's. So altogether, there's 5 variables in that term. All right, if I talk about the degree of the polynomial, that's just the highest degree we see. So I want to do a few examples of that, kind of explain what I'm talking about. Okay, so right here on your handout, I did actually type a couple. So this first one, how many terms is this one? 4 terms. Okay, if I'm looking at the degree of the polynomial, I have to find the highest degree. So what's the degree of the first term? 5. The second term? 4, 3, 2. So the biggest one is 5. All right, take a second and do the next one on your own. Figure out the degree of that polynomial. What do you think it would be? 8. Because this is 2, 2, and 8. So we take the biggest one. Are we good with that? So the last thing I'm going to do today, I'm done with terms. We're just going to do a few examples working with polynomials here at the end to wrap things up. So we'll see, you guys tell me. I have several examples, but if you remember, we don't have to do all of them. So take a second and write this one down, and we'll see if we remember what we can do.
So you want
So how do you add polynomials? Like terms. So we have a 17x to the third, so it's a like term with the negative 9x to the third. When you add those, you just add the coefficients. The variable part doesn't change. So 17 and negative 9 gives me 8x cubed.
We got 2. That's for x squared.
Negative 10x squared and positive 10x squared. Yeah, those cancel out. Positive x and negative 5x. Does it matter what order I write those in if I put negative 4x plus 8x cubed? No, I don't care what order they're in. You just have to have the right pieces. How is the second one different? Since it's subtracting, the easiest option is to distribute that negative through the second parenthesis and then add. Why don't you guys try that one? So the negative, you have to take it to every term. So it becomes a negative m to the fourth, a positive 6m squared, and negative 35. So negative 6m to the fourth and negative 1 would be negative 7m to the fourth. Negative 11 and positive 6 is negative 5m squared. 21 and negative 35 is negative 14. How'd you do? Good? Do we need more addition and subtraction practice?
Excuse me,
Stop there.
What?
third grade edition.
Third grade? Oh, that's
With that,
not
I'm actually in
fun.
5 minutes. Cooking thing. In 5 minutes. That new under 5 minutes.
What if?
Scissors?
Do you remember how to multiply?
Oil.
Okay.
Oh.
Don't worry, we're not going to divide. Multiplying is where I'm going to stop with this. So x times x,
X squared.
good, you add those exponents, plus 3x minus 3x.
As well.
I do not care how much work you show me, so whether you write this or not, that's totally up to you.
On everything.
In general, like if it's an obvious multi-step problem, you need something to justify your answer, but you don't have to write down every step for me.
Even on homework. So you're okay with mental math?
Negative 3 times positive 3,
Negative 9.
so we get x squared minus 9.
Brain wants to do differences.
Can I distribute that square?
No.
Why?
Yeah, boil. It's a lot.
It's got two terms, so it's a binomial. It means we have the whole parenthesis 2 times. So we have to. So 3x times 3x would be 9x squared. 3x plus or times 2 is 6x. 2 times 3x is 6x.
Oh no.
2 times 2 is 4. Add like terms. What do we do if it's not just a binomial times binomial? This is really my last example. What do I do on this?
Distribute.
Yeah, we can't just call it foiling, but it's the same premise. We just take everything in the first times everything in second. Sorry, we're gonna have space. Too many examples. So 4t times 3t squared. 12t to the third, right? 3 times 4. 4t times negative 2t. 4t times 7.
28.
And then we take everything times negative 5. So negative 5 times 3t squared. Negative 15t squared. Negative 5 times negative 2t. Positive 10t. And negative 5 times 7 is negative 35. Am I done?
No.
Why not?
You're gonna add, subtract your like term.
Okay. Negative 8t squared and negative 15t squared. 28t and 10t. Alright. So, homework.
Oh.
Right?
That's outrageous.
Okay, 2 things.
No, 2.
Two. First thing. This paper I gave you, what does it have at the bottom? Signature. So please, take it home. Actually have your parents sign it. Don't just sign it for them.
My mom just signed it.
That's nice of her. So get that signed. That's your first thing. Second thing, if you look on Google Classroom,
get to know me survey.
There was a survey I posted. Very short, just a few questions, kind of lets me get to know you a little bit more. So those are the 2 things I want you to do for tomorrow.
Towards back.
I know, it's rough. First week, no mercy.
How dare.
So, survey syllabus, please.
First day.